All right, hello. My name is Jay Poulton, and here we have the Circuit Solver V2. Um, I've upgraded it to a graphical interface, so you don't need to type into the terminal anymore like you did in the original version here. Here was my first video, nodal analysis, automated circuit solver, and we used this problem as a demo problem. So I'm going to use the same problem here because we know these results are correct, and you can do the math and test it yourself, but it is correct. So this should be the same program here, but now we have buttons, and there we go with the first error value must be numeric. So let's get started here. So first we have a resistor, and we'll say this is node 1, this is 2, this is 3. 4 can be this node, which we already know the voltage is going to be 12 right there. But we'll start with resistors. So from 1 to node 0, we have a 4 ohm resistor. So 4 from 1 to 0, enter. Pops up in this list up here. You also get an indicator of how many nodes are present right now. So right now we have node 0 and node 1, so a total of 2 nodes, ground included. Now we have an 8 ohm from 1 to 2, enter, and you notice that's the same as these two entries here from before, so now we just have this nice way of doing it. Um, Now we got a 4 ohm from 2 to 3. We have a 2 ohm from 2 to 0. We have a 8 ohm from 3 to 4. You can also say that this is an 8 ohm from 4 to 3, so we'll just say from 4 to 3. 8 from 4 to 3 to show that it doesn't matter which way you go. We got a 2 ohm from 1 to 3. And I believe that's all the resistors. So we have 1, 2, 3, 4, 5, 6 resistors. And now let's add the current source. So we can either type I or IS. Actually, it has to be I, or we can just select it from the drop down. And this is going to be important which way we label it because it has direction. So it's going to be 5 amp value from 0 to 1 because that's the way I've designed it. So you just go with the arrow. So from 0 to 1, enter. Now we have a 3 amp from 1 to 3. Let's go ahead and add that, 3 from 1 to 3. And we have a 12 volt voltage source from, this is actually going to be from 4 to 0 because I've done it with, if you were using a multimeter, you would put the positive on the positive, negative on ground, and it would be positive 12 from 4 to 0. So we have 12 from 4, oops, not 40, 4 to 0, enter. Okay, now we have our entire component list. We have 5 nodes, just like this one had. We had to manually enter how many nodes before, and we had to manually enter components. Now we don't even need to give a component number. We just enter the components, and it automatically detects how many nodes. And from here, we can just hit the solve button, and boom, we get our results. Solve number 1 right here, and we have all the answers just like we had over here. So we got what? V4 is 12, V2 is 4.9, V4 is 12, V2 is 4.9. So we get the same results. Now the cool thing with this program is instead of having to redo the whole thing and restart the program, if you accidentally mess something up or you want to change one of the values, you can just click it right here. Like we can put 15 volts, enter, press solve, and we get another solve. And now the value's changed corresponding to whatever we change up here. And you can also change from what node to what node. You can change any of this data. Now the control arms, those come in when you're dealing with dependent sources, which I could show a problem like that. In fact, let's go ahead and do it. Why not? So first, let's clear all the components. Let's clear the history. All right, so hopefully this guy has done his math correctly. Let's go ahead and match this circuit. So we have a 3 amp going from 0 to 1. So let's add that first. 3 from 0 to 1. We have a resistor 2 ohm from 1 to 2. Resistor 2 from 1 to 2. Resistor 8 from 2 to 3. Resistor 4 from 1 to 3. Resistor 4 from 2 to 0. And then we have a current controlled current source, CCCS, with a value of 2. It's the gain value that we want to put here, and times IX. IX is the controlling current, which goes from 1 to 2. So first of all, we got to put the direction here. It's going from 3 to 0, the current source itself. And then the control positive is going to be the 1, just like we did with the current source. It's going to be 1 to 2. And then if we hit enter, it pops up here. We can hit solve. And look at that. So we have V0 is 0, obviously. V1 is 4.8. V2 is 2.4. V3 is negative 2.4. And this is actually the current from 1 to 2. So this is the current IX going through here. And that's important. The solver automatically generates that to deal with this while it performs KCL. So there's proof right there that it works, and that's it, man. Like, talk about making your homework easier or checking your answers on your homework. This is a very powerful, simple tool that you don't need anything else to do it. You just plug in your circuit and go ahead and check your answers from there. But yeah, so my name is Jay Poulton. This is Circuit Solver V2, or sorry, V3, and I have V5 coming out soon, which is going to allow you to draw the schematic and solve from there without even typing anything in at all, just by simply matching the schematic. And so yeah, that'll be pretty cool. But all right, peace.